Alright guys, I've got a fairly easy lesson for you today since I'm gone. We're going to be doing the Pythagorean theorem. We're going to start doing something a little different with it than you've done before, but not any more difficult. Normally when you have the Pythagorean theorem, you've used it to find a missing side length. Today we're going to start by proving triangles are right triangles. And it's not any more difficult than finding the one side. It's actually, if anything, a little easier. What we're doing is using a squared plus b squared equals c squared. And if I add a squared to b squared and it equals c squared, then it is a right triangle. If I add a squared to b squared and it doesn't equal c squared, then it's not a right triangle. Really straightforward to begin with and can't make it much easier. So I give you this first example. 8 squared plus 11 squared equals 14 squared. We know C has to be 14 because it's the longest side. You always want to make sure that your longest side is C squared. So it gives you 64 plus 121 equals 196. And if you look, that totals out to be 185 equals 196, and that doesn't work. So that's false. It's not a right triangle. I'll give you a second example down here, and you can read, so I'm not going to read it for you, but it essentially said you square those and add them, and they do equal each other, so it is a right triangle. Not rocket surgery here. We're going to keep going with it. So let's actually do an example together. And it's wanting us to do true or false on here. You can write T or F. You can bubble at the bottom. I really don't care which one you do, but make sure you do one of them and make sure it's very clear and make sure you do it all of the time. Don't do it one way for a little while and then switch to the other. That's very annoying. So this first one, we have the lengths of 20, 21, and 29. 29 is the longest side we have. So we're going to make it c squared. The other two doesn't matter. So let's zoom in a little bit here so we got a little more room to write. So I'm going to set it up. 20 squared plus 21 squared equals 29 squared. And again, of those, it doesn't really matter which way I have 20 and 21, and what order they're in. What matters is that I've got the longest side, in this case 29, as c squared. So I do this out. 20 squared is 400 plus 21 squared gives me 441 equals 29 squared, which is 841. Now for this to be true, when I add these two numbers together, it has to equal the third one. And most of you can do mental math there. That does in fact equal 841. So this one is true. It is in fact a right triangle. Yes, this first part is that easy. Going to number 2. So again, setting it up. The thing you have to pay attention to is, did they give me the biggest one last? I'm 35. You've got to pay attention where the biggest side is. That's the biggest challenge of this one. So 12 squared plus 16 squared equals 35 squared. So we do 12 squared, which is 144. It's supposed to be a plus sign there, not an equal sign. And then we do 16 squared, which is 256. And if it's a right triangle, then it will equal 35 squared, which is 1,225. Now, just an initial look at this, that doesn't look like it's going to work. I mean, again, mental math, most of you can tell that's going to be not 1,225. But for math's sake and example's sake, we're going to do the math there. So we do 144 plus 256, and we get 400 equals 1,225. So in this case, this is false. All right. So as you're working through these, again, it really is that simple all the way through. Your biggest challenge is making sure that they put the largest side as the third one. And as you go through, you can see there's not a whole lot of these. This is pretty easy. There's not a reason to do a whole lot of these. And just checking that they see to see that they did in fact make that largest side last. And on all of these, they were nice and made all of them last. But you can't assume that. You do need to actually check and pay attention, right? So those 2 pages there should take you, I don't know, 45 seconds. Some of you probably finished it while I was going through the examples. Not terribly difficult. So we're going to our other work. I'm going to start on this one, and this one is closer to what you're used to using the Pythagorean theorem for. In this case, we have to set up a squared plus b squared equals c squared. You notice that you're going to need some extra paper for work here because I am telling you, you have to show your work on this, at least the setup of the a squared plus b squared equals c squared, so that I can tell you know where a, b, and c are. All right? Yes, I know that's mean. I'm making you write down work, but you'll get over it. Quit complaining. Now, you write this down. There's not enough room on here to do it properly. Please do not try to cram it in there. I don't want to try to have to decipher that. Use a separate piece of paper. If you don't have paper, feel free to mooch off your neighbors. They probably have one. Now, on this, we've got your right triangle. The way you know where C is it's across from the right angle. Always across from the right angle. It's not always X. All right? These first couple, it's X. You got that hypotenuse across from the right angle. You get to number 4, it's not anymore. So we're going to start. I'm going to do it over here on the edge of my paper. A and B don't matter. It's those 2 sides there. Which one's which doesn't matter on that. So I've got 9 squared plus 12 squared equals c squared, or x squared in this case. All right? So we start off by doing 9 squared, which gets me 81, plus 12 squared, which is 144, equals c squared. Do 81 plus 144 gives me 225 equals c squared. And you do the square root of 225. Is 15. Now, in case you're not sure why I did the square root there, I've got to get rid of this c squared. In case you have forgotten, that gives me c squared. I need c, just the length of that side. So what I'm going to do to get rid of that squared is I actually square root both sides. so that it goes away. And all I'm left with is C. Alright, so on this one, x equals 15. Alright, that's more what you're used to doing. Those first three, a squared plus b squared equals c squared. Don't forget to square root to find your answer. Then they change things up just a little bit, and they don't give you both sides and the both sides looking for the hypotenuse. They give you one side and the hypotenuse, and want you to find the other missing side. So, coming over here in the margin again, call this one number 4. So I have a squared plus 6 squared equals 10 squared. Again, if you wanted to choose b squared instead of a squared, that really doesn't matter at all. What matters is that I've got my hypotenuse, the one directly across from the right angle, all by itself on one side of the equal sign. And again, it's always across from that right angle there. Now, that's initial setup. Some of you have probably had teachers in the past tell you that if you're missing a side, to set it up differently. And for me, that's one more thing to remember, and it seems silly to remember to set it up that way when you guys know how to solve equations. Alright? So, if I told you to do it this way, hopefully I'm not confusing you. If you remember it from, 7th grade math or whenever you did it there, and they had you set it up as c squared minus a squared equals b squared, you can do it that way. But again, to me, that seems like one more thing to remember and seems kind of silly since you already know how to solve equations. So what I'm going to do is I'm going to go ahead and solve what I know there. 6 squared is 36, 10 squared is 100. I'm working on getting a squared by itself. So positive 36. I'm going to subtract that. Gives me a squared equals 64. Then I have to square root both sides. A equals 8. Now, I used a over here because I was talking about a, b, and c. When I get back over here, they gave me the variable x, so I'm going to need to write x equals 8. If you wanted to write x over here instead of a, you could. That's not wrong. I just did that to stay with our a, b, and c. Right? So the only one that's really different on this sheet, or really the only two, you've got this guy over here, where you're finding two sides on two separate triangles. Right? Big thing to realize, this 9 goes with that triangle. This 5 is a shared side on both triangles. This 3 goes with that triangle. So you got two sides to find, but you have two separate triangles. It's really not any different. This one is a word problem, and the biggest challenge for some of you is remembering how to read. So when you do ladders leaning against the side of a 10-meter house, if the base of the ladder is 3 meters away from the house, how tall is the ladder? It says, draw a diagram. Well, you don't have to draw an actual house. You really can if you want to. There's a house. You have 10 meters tall from where it's touching the house. So we're not really talking about the top of the house. We're talking about where the ladder touches the house. So from here to here, we have 10 meters. We have a ladder leaning against it, and the base of the ladder is 3 meters away. Obviously, this is not to scale. You've got the base of your triangle, you've got the side of your triangle, you're looking for the hypotenuse. So you have A, you have B, you're looking for C. Pretty straightforward. I have faith in all of you to be able to find that. On this one, we're looking for the length of a diagonal. So what they've done is they've given us a rectangle here. They've given us the two side lengths. They want us to do a squared plus b squared equals c squared. Pretty straightforward. BD, they gave us the hypotenuse and wants to find a side. The challenge here is that they gave us the entire base of the triangle. Now, we haven't talked about this a whole lot, but we did mention before a perpendicular bisector, and it forms in a right triangle here. We drop perpendicularly to the base, and what happens is we're going to have a bisector there, and this triangle is going to be congruent on each side of that. So what we actually wind up using is half of that is 5. So we'll have 5 for A, and then we'll have 13 for C, and we're looking for B. Down here, just like our other sheet, a squared plus b squared equals c squared. The challenge on this one is that they don't put them in order for you. You actually have to pay attention and realize what the longest side is so you can put it as c squared. Pay attention to your directions, because if you notice, it tells you to round to a certain decimal place. Hopefully you can figure out how many places that is. If not, you can Google which decimal place that is. We'll take a second to pause here, because at some point in time, you're probably going to go, Mr. Mitchell's going too fast and I need to rewind. Whether it's here, whether it's the review that's coming after this, whatever the case is. Remember, it's a video. Pause, rewind, fast forward, whatever you need to do. I always have people afterwards that have told me, you were talking too quickly, you were moving too quickly. Well, pause the video. Duh. Anyway, sarcasm aside, sorry. Coming back to it, solve each of the following, draw a picture and use the Pythagorean theorem to solve. Be sure to label all answers and leave answers in exact simplified form. So, here's where things can get fun. So you start off, draw a picture. And again, I really don't care if you draw an actual picture. This is not art class, but if you want to make it a little more fun and draw an actual picture, go for it. Bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long. So your important parts there, 3 feet from a wall, 12 feet long. It wants to know, how far above the ground is it? So you're given probably the most common Pythagorean theorem problem ever is you've got a ladder against a wall. It tells you it's 3 feet from the wall, and tells you the ladder is 12 feet long. This is the ladder, so that's 12 feet long. All right? Be careful when labeling. Just make sure that you actually label properly. All right? If you label everything the way you're supposed to, won't be an issue. A squared plus b squared equals c squared, so you go to solve. You've got 3 squared plus b squared equals 12 squared. And solve just like we did on the other ones. Again, reminding you, if you remembered from 7th grade math or whenever it was you learned the Pythagorean theorem, in your particular instance, you remembered your teacher told you to set it up a certain way, you can do that. But as I've said before, it seems a little silly to me to remember a new way to set it up when you already know how to set it up and you know how to solve equations. Just seems a little silly to me. You get b squared sorry, having some issues writing there. It's not registering everything the way it's supposed to 100%. It's taken me once or twice to write it there. There we go. Now, if you will notice, when you punch in 135 on your calculator and go to square root, it is not a perfect square. Not even close. You do the square root of 135 is like 11.6 horrible decimal that follows. It doesn't want us to do a decimal. It doesn't want us to round. Exact simplified form. All right? So, pardon me. If it comes out to be a perfect square, get a nice, simple, plain number, great, write it down. If it happens that you get a terminating decimal, so it goes 6.584 and it stops, write that down, you're good. But if it's like this one, and it's a non-terminating decimal, so it goes on forever, we're not going to round. We are going to attempt to simplify that radical, which is what we were working on yesterday. It's why we did it before the Pythagorean theorem. So I'm going to come over here, and I'm going to work on simplifying my radical. Excuse me. I'm going to set my work over to the side. So I've got the square root of 135. All right. So this is where I start taking those perfect squares that I had before that you should have written down. Okay. And here they are again in case you were a slacker and didn't write those down. So those are the most common ones. Obviously, those are not the only perfect squares because numbers never end, so I could square any number regardless how big, and it keeps going, but you don't care about that. So these are the ones you'll see the most. Not the only ones, but the most. So what we're going to do is we're looking for the biggest one of these numbers that divides evenly into 135. If you're not sure, take out your calculator and do 135 divided by 1. Well, that one's going to work. It works for all of them. So I go to the next one, 135 divided by 4. It doesn't work. 135 divided by 9. It does work. And because it works, I'm going to write it down. So I've got square root of 9 times the square root of 15. All right? And you can check other ones. But as you check your other ones, you're going to see that none of them work. That was the only perfect square that divides evenly into it. When I say divides evenly, I mean that there's no decimal left over. So the reason I chose this one is because that's a perfect square. I can now take the square root of it. Square root of 9 is 3 times the square root of 15. That won't change any. So square root of 15. And before I say that's my final answer on that, I'm going to take and check real quick 15 and see if any of those divide evenly into it, and none of them do. So this is my final answer. And when I come back over to my paper, and I write 3 on the square root of 15. Now, I know some of you are going to say, Mr. Mitchell, we've only been working on that a day or two. How am I supposed to remember how to do that? Well, if you're struggling too much, you can always Google how to simplify radicals. That's what we're doing there, simplifying radicals. Know that, at least getting this far, knowing that b is the square root of 135 is going to get you at least partial credit. But go ahead and figure, give it a shot on that. Now, I know some of you are smart enough to figure out, hey, since he told me I can Google stuff, why don't I just Google what the simplified radical of 135 is? I know how your brain works. I know that Google will do that for you. What Google won't do for you is take your quiz and your test for you. You need to know how to do this for the test. Classwork counts for a lot less than tests and quizzes do. This is coming back on a test, guarantee. Now would be the time to learn it. Now would be the time to mess up on it, to try to figure things out, to work through it, and to make a mistake if necessary. And then it's a little percentage off as opposed to making a mistake on a quiz that's coming up soon and making a bigger mistake and then repeating it on a test because we still didn't learn how to do it. All right? So take the time, learn how to do it. If you need to Google help, there are lots of videos on simplifying radicals. The big thing's just remembering which perfect square divides evenly into it. We did a bunch of those. You guys can do it. I have faith in you. Moving along to our next page. The big thing you're going to need on this one that you may or may not remember is the area of a triangle. The formula for area of a triangle. It's not that difficult. You've done it before. But just in case you've forgotten, area equals 1/2 base times height. So on this one, it tells me that my right triangle, I've got two sides. It wants to know what the area is if these are legs. So 8 inches, 12 inches. Don't criticize my triangle. I hear some of you going, the triangle's funky. Shh, be quiet. So, area, I just plugged those in. So I've got 1/2 times base, and it doesn't matter which one's which. In this case, that's the base. But since multiplication is commutative, it doesn't matter what order we do it in. 8 times 12. And that gets me my area equaling 48. Now, it gave me units of measurement. It's a word problem. I need units of measurements and or words in my answer. So area equals 48 inches squared because it's area. I have square units for area. Now what changes a little bit, is on my next one, I'm given a leg and a hypotenuse. And I know 12 is the hypotenuse, and people always ask, well, I don't know which one's which. The hypotenuse is always the longest side, always. So that has to be the hypotenuse. We've solved already how to figure out that missing side. You're going to have to simplify on this one. It's a little tricky, all right, because you're going to have a simplified radical. You can still figure out the area of a triangle on there. I have faith in you. Give it a try. That's all I ask. All right. These other ones, there's some tougher word problems on here. But you can think through these. Perimeter of a square, if they gave you the area, the key word there is that it's a square. All right. If you know it's a square, you know all four sides are the same. Think about that when you're doing your area. It's going to be the same thing multiplied. Trying not to give you the answer, but trying to help you out. A isosceles triangle has congruent sides of 20 centimeters, base is 10 centimeters. What's the area of the triangle? All right. What we're going to know on this one, and I'm going to remind you in case you didn't remember from the other one, we've got an isosceles triangle. We've got a perpendicular line dropped there for our height. What's going to happen, see it says congruent sides, that's these guys, are 20 centimeters. And the base is 10. When I have an isosceles triangle, if I drop my perpendicular height there, what happens is it cuts that base in exactly half. It becomes a perpendicular bisector. That'll help you when finding the area of that, because what you have to do is find that height. It doesn't give it to you. So you have to use your c squared and your a squared to find b. All right? Trying to help you with some of the basic setups on those. Baseball diamond is a square. Square. 90 feet on each side. If a player throws from second base to home, how far will the ball travel? The challenge for some of you is going, I don't play baseball. Well, you got a diamond. We're saying it's a square, so all four sides are the same. And they're all 90 feet. It went from second base to home plate. All right? And last but not least, we've got Jill and her table trying to make it through the door. And most people's initial reaction is, no, it won't fit because it's bigger around than it is wide or tall. Not thinking about the fact that your door is a rectangle and is therefore going to be longer on the diagonal. So you've got 42 inches and 84 inches. Now, it doesn't really care what this diagonal is. Only is it bigger or smaller than 96 inches. So it's not going to come out to an exact number on there. But that doesn't matter. I don't care what that number is. I just want to know, is it bigger or smaller than 96 inches? If it's bigger than 96 inches, yes, it'll fit. Or if it happens to come out to be exactly 96 inches, either way, still fits. If it's less than 96 inches, it doesn't work, okay? It doesn't matter if it's even close. So 95.9 inches doesn't matter, because that table's not going to shrink a tenth of an inch. I seriously doubt Jill's going to take out the sander and sand down her table so it fits in. Alright? Alright, so that's basic lesson on Pythagorean theorem there. That's probably not going to take you all that long, but I also promised you review for your quiz that you've got last about 20 minutes of class. So, review time. So I told you your quiz is coming up on similar triangles, and it's at the end of the course, or the end of the day rather. If you need a little review, you can use this time for that. If you don't need the review, then if you finished your other work, you're ahead of the game. Wouldn't hurt to watch this just to remind you before you start your quiz. Similar triangles, the only difference in similar triangles is their size. One's bigger than the other. All of those are similar. The only difference is one's bigger than some are bigger than others. Some are flipped, some are rotated. That's the only difference going around. All of their angles are equal. Corresponding sides have the same ratio. And that's an important part. So 1 and 2 on that angle, 1 and 2, so those two sides are corresponding. They have the same ratio. Over here I've got 1 and 2. Obviously that's been flipped and rotated a little bit. That we've got that side's going to be corresponding to this side over here. Alright, they're going to have the same ratio. I'm going to talk about setting up ratios in a little bit. Those similarity, angle, postulates, and theorems, I'm not going to read them to you, just mainly, if nothing else, to save my voice, and you're probably already a little tired of listening to me. So, feel free to pause this if you want to read that a little more carefully, and that way you don't have to listen to me reading to you when you can read yourself. Breaking it down a little bit, I will talk to you about those. I'm not going to read that again, but knowing at least two angles are the same in the triangle. Any two angles that are the same. Now, an example or two that we did, if we have two triangles, and they give me that one's congruent to this one, they give me that one and this one, right? We don't have the same two angles. We can't assume that these two triangles over here are similar. These two are. So this one right here and this one right here. We can't assume that these two are. Now, if instead of just giving congruency marks, if instead of just giving us congruency marks, they were to give us numbers, so that's, get rid of my pointer there, 24 degrees, and this one's 80 degrees, and they tell this one is 24 degrees, and the other is 76 degrees. We could figure out whether or not those are similar. We know those two angles are the same. If we add and subtract from 180, we know that this angle over here has to be 80 degrees. Same thing over here. If we add and subtract from 180, we know that this angle over here has to be 76 degrees. They wind up to be the same. So if they've just got markings, you got to have the same markings. But if they give you degree measurements, you could actually plug it in and tell from that way. Side, side, side. You got to have all three sides marked. If all three sides are not marked, you cannot use side, side, side similarity. So using side, side similarity requires us to set up ratios. Corresponding sides, doesn't matter which one we put on top. So 9/3, because 9 and 3 correspond on this triangle. 12 and 4 correspond. And I'm going to do 12/4 because my first one I did big triangle over little triangle. So all the rest of them have to be big over little. Alright? So I do 15/5. And these all need to simplify to be the same number for it to be similar. So it's 3, 3, 3. Those all simplify to the same number, so they are similar. If I were to get one, that one of those ratios was different from the other two, or if they're all three different, then it's not similar. Okay? Side angle side. The biggest thing, just like when we were doing congruency, that people mess up is not paying attention to where that angle is. Alright? That angle has to be between the two sides. I've said before it has to be touching both sides. Some people get that, some people don't. You got to know it's between. It's got to be in order. Side, angle, side. And on top of that, it also has to have the same ratio again. So 7/3. I set up the other one, big triangle to little triangle, 7/3. Those don't simplify at all, but they're exactly the same. So that means those two are similar because that angle is also the same. Alright, I have to have two pairs of sides with the same ratio and a congruent angle between them. So that's proving similarity. We're going to put that into practice a little bit. This one we have three sides marked. So the initial thought is probably side, side, side similarity. But we have to check those ratios. All right? What we're going to do is match up long side to long side, short side to short side, etc. So 24, if I'm looking how this is turned here, 24 is going to match 56, 28 is going to match 72, 14 is going to match 28. All right? So I'm going to set those up. 14 over 28. I'm going to set up 24 over 56. I'm going to set up 28. Give myself a little more room there. 28 over 72. All right. For these to be similar triangles, all of these have to have the same ratio. So that's going to be 1/2. This one is going to be 3/7. And this one gives me 7 over 18. Now, I could have stopped after the first one that was different. But seeing that they're all three different makes it even more certain that there is no way that those two triangles are similar. So we would put not similar. And that's the similarity symbol, in case you were wondering. It's also right there. Now, we cannot write a similarity statement for this triangle because they are not similar. If they are not similar, do not write a similarity statement. It's that simple. We got another one here. Got an angle marked, but we can also figure out vertical angles. So we'll say those. Let's mark those with a double mark. There we go. Now, I have two angles in each triangle. The problem is I don't have the same two angles in a triangle. All right? I know that these two are the same as each other. I know I have an angle marked, but it's not the same as that one. So 2 marks, 1 mark, I fixed it, went back there. I realized that that had 2, not 3. So I need to have a third one there that wasn't used. Most people see 2 angles marked and want to call it similar, but remember what I said, they have to be the same 2. So those 2 are not similar. Now, this one, again, we have one marked, this time the same in each triangle. And we also have our vertical angles. All right. Now we have 2 angles in each. 1 mark, 2 marks, 1 mark, 2 marks. These are similar because of the angle-angle similarity postulate. Now we have to write a triangle similarity statement. Like a triangle congruent statement, they have to be in the same order. So this first one I did ZYK. So I'm going to start with Z. And I'm going to look at my road map here. I'm going to look at my congruency markers to help me out. Z is unique in that it has no markings on it at all. So I go over to my other triangle over here. The angle with no markings on it at all is G. So I need to start over here with a G. My next letter, Y, has 2 markings on it. Well, this is going to be Y again. Another thing that helps me out with that is a shared point. Anytime I have a shared point, see both triangles have Y on them, they need to be in the same spot in similarity. See, the Y is second, the Y is second. The only one that's left is H. It's the one I haven't used, so it has to be last. And again, just checking my that it's corresponding there. I've got K. K's got 1 mark. H has 1 mark. So they're in the same order. That's something that is important to check on your similarity statements. So our next one here, we've got two pairs of sides marked. We also have that set of vertical angles again. So I'm going to mark those. Now, it's looking like side angle side, but we can't assume that. What we have to do is check our ratios and make sure they work. Now, I'm going to put corresponding side with corresponding side. So 96 is the shorter of those two. It matches with 24 because it's the shorter of those two. You see? 112 is longer, 28 is longer. A lot of people will mess this up because they get those backwards. So I got to make sure it's with the corresponding side. So 96 over 24. And I've got 112 over 28. So for these to be congruent with side angle side, those have to simplify to be the same ratio, same number, whether it's a fraction or whether it's a whole number. And what I get when I simplify that is that both of them equal 4. So I've got two pairs of sides with similar ratios, or congruent ratios, they're the same ratio. I've got a pair of congruent angles, and that angle is between the two sides. It's a lot of things to make sure you have, but it's important to check all of them. So this one is similar because of the side angle side similarity postulate. Now what I have to do is check to make sure that when I write my congruent statement, or excuse me, my similarity statement, like my congruent statement, that it needs to be in order. So when I get over here, I'm going to make sure it's in the same order. So SYH, I'm going to use my markers best I can. So S, it was on the short side opposite of 1 mark. So I need to look on my other triangle. I need the short side opposite of 1 mark. So I need to start with the N. Switch to my pen. N. There we go. Then I go to Y. Y is that shared point again. You notice it's second. It needs to be second on mine. And the last thing that's left is D, so it has to be last. Alright? Gotta make sure it's last. Now, I've noticed on my similarity statement over here, on ZYK and GYH, I did not put my triangle before it. I'll fix that. That's for you, Jim. Alright. Alright, so for these two, they don't want to know whether or not they're similar. They tell us they're similar, and they want to know what the missing side is. So we got all three angles. We know they're similar triangles. We've got to set up our ratio. Now, again, some of you can see, because this one's a fairly easy one, say, oh, well, I've doubled 6 to get 12. I'm going to double 10 to get X. But when we get one that's more difficult, it's nice to remember how to do the proportion. So again, you got to set up corresponding sides. So 10 goes with X. And 6 goes with 12. What's going to happen is I'm going to cross multiply and divide on this one. So 10 times 12, 120, divided by 6, X equals 20. Alright? With your second example, I've got two known sides, two known ratios there, and then I've got one that's missing. So I'm going to set up a ratio of ones that are known, 4 over 2, equals one that's unknown, 6 over S. Now I could just as easily have used 10 and 5 as well, but I don't need to do that. You only need to pick one. So I'm going to cross multiply to numbers. Some people get confused because they're not sure how to multiply s. Use your numbers. 2 times 6 is 12. Divided by 4, s has to equal 3. And yes, I switched to cursive. Alright. Word problems are everybody's favorites. Again, they tend to be tricky because they make you read and do math at the same time. So, tree 24 feet tall. Cast a shadow that's 12 feet long. Brad is 6 feet tall. How long is his shadow? So, we got a tree, 24 feet tall. Let's back that up. Let's make our colors match here. 24 feet tall for our tree. Cast a shadow 12 feet long. Brad is 6 feet tall. How long is his shadow going to be? Alright. All of that's in feet. Units are important. So I'm going to set up my corresponding ratio. So 24 over 6. 24 over 6 equals 12 over x. And then I'm going to cross multiply and divide. Alright. X is going to equal 3. And again, that's another kind of easy one because you can see those things, but it's nice to know how to set up that proportion to solve when you get one that's a little more difficult. Alright? So that's a quick and easy review of similar triangles. If you're needing a little more in-depth review and you've got extra time before your quiz, you're welcome to Google some extra videos on there. There are lots out there on similar triangles, solving similar triangles, proving similar triangles. All those things are possible on your test, your quiz. I almost called it a test. It's a quiz. Know these things. Watch the video multiple times if you need to. Pause it, stop, rewind, listen to it, do screenshots, whatever you need to do to help you study for that. Feel free to do that. When you take your quiz, remember you're not allowed to have any electronic devices out except calculators. If you need a calculator, you may borrow one. You may not use your cell phone on the quiz. Absolutely no exceptions. If you need to turn one in, that's fine, but absolutely no exceptions on that. Alright? I will be by this afternoon to collect papers. Feel free to turn any of these in that you finish. Those are expected to be done by the end of the day. I think most of you will finish with plenty of time left over. Be aware that I will be checking those. I will be seeing how you do. We will be quizzing on those, and I'll even change the video for tomorrow a little bit if I need to, if I see you guys are struggling. Feel free to send me emails if you have questions, and I will see you guys as quick as I can get back. Hope you guys have a great day.